This video is to algebraically derive the cofunction identities. So sine and cosine are cofunctions. Tangent and cotangent are cofunctions. And finally, cosecant and secant are cofunctions, and there are identities that connect them. And we already know the Pythagorean identity that connects sine and cosine, but this is another way to get one in terms of the other. And so I want to give kind of a visual for sine and cosine, but then do the algebraic. So if you're looking at some angle theta, and I put it in the first quadrant, doesn't really matter, then, and let me put it in a better spot, that's too much towards the center, so let me just stick it there. So we can see that for this particular spot, and I don't mean that to be pi 6, it's just some spot there, but we can sort of see that the cosine of theta is a pretty big number. It's almost 1. And the sine of theta is, I don't know, not quite a half, but relatively small compared to the cosine. So when I look at what do I get when I do a quarter of the way around the circle, 90 degrees, and then take away this theta? And so we see quarter of the way through up there at pi halves, but when I go back, this theta amount, as if this amount of angle is theta, then this is, let me do it in orange, this is the full pi halves take away theta. And what we can sort of visually see is, it seems as if, anyways, that the cosine of pi halves minus theta is about the same as the sine of theta. They seem to be at about the same spot, not quite a half. And similarly, let me move this over. I didn't give myself enough space. Similarly, the sine of pi halves minus theta, which is the y-coordinate here, is just about the same as the x-coordinate, the cosine, for theta. And that's what we're going to algebraically sort of show. So we're going to use those cosine of a sum and cosine of a difference identities. So a quick reminder of what those are. Cosine of the difference of two angles is cosine of the first, cosine of the second, plus sine of the first, sine of the second. And if this happened to be plus cosine of alpha plus beta, same exact formula, cosine of alpha, cosine of beta. It's just now it's minus sine of alpha, sine of beta. So as you start to just do these over and over again, it starts to get in your mind, and you don't need to derive it over again. You just go, okay, I got that. But warning, if you go for a week without looking at it, you start to forget. It's just how our brains work. So what I'm going to do is I'm going to look at, okay, so what is the cosine of pi halves minus some theta? And I'm going to use the first one of these and say, okay, that's the cosine of the first thing here, so cosine of pi halves times the cosine of the second thing, okay, great, plus the sine of the first one in the difference times the sine of the second one in the difference. Doesn't matter if you call it alpha and beta or pi halves and theta, it doesn't really matter. It's just the cosine of the first times the cosine of the second plus the sine of the first times the sine of the second. But hold on there, I know the cosine of pi halves, that's just the x-coordinate up here. So that's 0. And I know the sine of pi halves, that's just the y-coordinate up there, and so that's 1. And so what this turns into, cosine of pi halves minus theta, that's just 0, because this whole bit, 0 times cosine whatever, that's just 0, plus 1 times sine theta, it's just sine theta. And if I were to do kind of a tricky thing, this is, you know, who comes up with this stuff originally? Very, very clever. But if I were to now try to figure out, okay, what is sine of pi halves minus theta? Well, that's just cosine of, now let me be careful here and try to be as clear as possible. We just said that sine of some angle is the same as cosine of pi halves minus that angle. And here I have sine of some angle. That's going to be cosine of pi halves minus that angle. So I kind of use this first thing that we got, that cosine of pi halves minus any old angle is sine of that angle, and then twisted it and said, oh, I'm going to call this the angle. Maybe I should call it alpha instead of theta, so that it doesn't get confused with that other thing. But, you know, sine of some angle, according to this one we just did, is cosine of pi halves minus that angle. Well, this simplifies. Cosine of pi halves minus theta. The minus distributes, and so I have pi halves minus pi halves. Well, that's nothing. Minus minus theta, that's plain old theta. So this is kind of cool. Not only is cosine of pi halves minus theta equal to sine of theta, but sine of pi halves minus theta is equal to cosine of theta. They have the exact same relationship with each other, that if I just take a quarter of a rotation around the circle and go back whatever angle I started with, I switch the x and y coordinate values. And kind of cool. The other ones just kind of fall out from these two. So for example, I'm not going to do them all, but because I'm already at 8 minutes here, but tangent of pi halves minus theta, well, that's, you know, tangent of anything is sine of it over cosine of it. But each one of these can be replaced with what we just did. Sine of pi halves minus theta, well, that's just cosine of theta. And cosine of pi halves minus theta, well, that's just sine of theta. And what is cosine theta over sine of theta? That's just cotangent of theta. And you'd get the same kind of thing going on if you started with cotangent of pi halves minus theta. You'd blah, 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 do a little bit of this with sine and cosine, and all of a sudden you'd get that was tangent theta. Similarly, secant and cosecant have the same relationship, that secant of pi halves minus theta is the same as cosecant of theta. And cosecant of pi halves minus theta is secant of theta.